Thank you, Felix, for your kind introductions. Good morning, everybody. So I'm Joanne Rout. I've been around the process industry since the mid-1980s. And I'd like to thank Felix and everybody else at NEPIC for giving me the opportunity to speak to you all today. It has been a challenge to condense the knowledge of and hundreds of years of accumulated experience that ITS has in its engineering team into a short presentation. But today I'm going to present some high-level insights illustrated by some real case studies. If you'd like any further information, please ask a question at the Q&A or contact me later. My contact details are on the final slide. Also, ITS have a virtual booth at the conference today, and my colleagues Trina and Robin will be happy to meet you. Today, here's a short summary of what I'm going to cover. Firstly, a brief introduction into our company, Industrial Technology Systems Limited, and then I'll talk about some of the challenges of optimising performance of legacy and obsolescent control systems, information systems, supervisory systems. Finally, I'll present some upgrade strategies illustrated with some case studies. So who are ITS? Industrial Technology Systems Limited is the UK's leading independent systems integrator. We design, configure, implement management information systems, process control systems, vision systems. We can also provide project management and engineering resource with the appropriate expertise in this area, and have regulatory compliance services and provide training. It has an excellent health, safety and environmental record, had 0 REDOR in 29 years, and we've also recently become carbon neutral. ITS is certified to ISO 9001 and 14001 and has been for many years. The company was originally founded nearly 30 years ago by Malcolm Knott, who was an engineer at ICI, working on industrial automation. In 2020, earlier this year, Malcolm won the NEPIC Outstanding Achievement Award. This was awarded for his successes in business, in the process engineering sector, but also for his local community work, including support for apprentices, careers at schools, and recently we've started supporting children challenging industry. Also regularly donate to Battlewick and Teesside hospices and sponsor local children's and amateur sports teams. So here's some of the customers that ITS have been supporting over the last 30 years. As you can see, they are leading companies in the highly regulated sectors. ITS supports its customers from its Middlesbrough and its Warrington offices, and only a few are shown here. There are actually many more. We have excellent relationships with the key automation suppliers. Some of them are shown here, but ITS is independent and system agnostic. Our philosophy is to use our extensive knowledge and expertise to identify the best value system solutions for our clients. So most of these companies we deal with have invested a significant amount in a system, maybe not recently. So let's consider what might be the objectives of a company considering and justifying further investment. Firstly, to prolong the life of the existing systems, but at the same time make sure that products can be made safely, consistently, efficiently, profitably. And what's really important is to minimise the downtime, which moves on to my next point. Reliability. So make sure that the system, if you're prolonging its life, is maintained the reliability is maintained or possibly improved. Systems are generally really reliable, but if they do fail, the resultant plant outages, if unplanned, can be very costly, as most of you will be aware. And of course, could possibly, if there's a failure, there's possibly a risk of an incident. Another reason for investing might be to give additional functionality. For example, some companies would like to have wider access to the real-time plant information, so they can do analysis, modelling, optimisation, reporting, etc. There are also new features that might deliver built-in safety. Of course, an area that is a particular concern at the moment is cybersecurity. They're becoming a more important factor, and obviously there's interest from HSE. Lots of systems have been built with firewalls or air-gapped, but requests for remote access are increasing, especially working from home or remotely with COVID, and that increases the risk. So ITS has the expertise to advise on cybersecurity issues for operational technology, or liaise with your IT departments to offer monitoring to assess the risks through using its partner Radiflow. So future-proofing your system, we recommend that you have a support and upgrade strategy to achieve the functionality to meet your current requirements, and also prepare for the future by planning where you want to take the system in the longer term. That may be a full system replacement, if that's the best option and there's capital available. However, ITS understands that can be hard to deliver the capital to deliver the required return on investment on a capital project to replace systems. So many are operating and will continue to operate legacy or obsolescent system. So I'll move on now to what are some of the challenges of operating these kinds of systems. Firstly, hardware obsolescence. The hardware supplied by the main vendors is robust and has a very long lifetime, but eventually they will be replacing the hardware with improved versions, and eventually spares won't be available. Regarding the software, that's also regularly updated, with which is good because they bring in beneficial additional features. However, the downside is that the support for the older versions will be phased out sooner or later. Another challenge is that the new software that's developed is designed to run on the newer operating systems, and that can also lead to hardware obsolescence. So just an everyday example of that is that, you know, when they brought out the track and trace NHS COVID apps, many people found that they couldn't use it because they had an iPhone 6 or earlier. And that's, although the phone worked perfectly fine with lots of other apps, this particular app maybe required more memory, more security features, and it wouldn't work on the old iPhone. So that meant that potentially that hardware becomes obsolescent. And we have other experiences of that. For example, the computer that might sit on your desk at work or at home, who's not very many of us here won't have had to upgrade to a new version of Windows operating system. Remember XP, Windows 7, some people might be using that still, and Windows 10. And we upgrade to be able to allow us to run new software, or because Microsoft no longer supports the older operating system and no longer supplies security patches. So obviously there's benefits. You get benefits when you move to a new operating system or new software. For example, Windows 10 offers more security, which is good against the increasing number of cybersecurity threats. However, the downside is when you upgrade to a new operating system, you might also have to invest in a new PC or laptop. And many of us will upgrade our personal or office phones, tablets, laptops every few years. But often there's not the same investment available to upgrade that hardware and software in the process plant control systems. And that's fine. While the system's running smoothly, it's quite often hard to justify investment in new hardware, but there are some cautionary tales out there. One of my colleagues described an example where the failure of a 5-year-old PC led to some serious problems on a renewable energy plant. The view to the plant was lost and had to be shut down manually. Then the company then took the decision that it wouldn't just replace that HMI hardware, but also on the other plants that ran similar hardware, because they couldn't face the repetition of the same unplanned shutdown outage. So that PC failure meant that they didn't take a planned approach, and probably led to a higher cost than if they'd picked that up earlier and planned for it. So my final point here is about system documentation. Quite often the documentation on how the original system was designed and configured or might not have been kept up to date as it evolves. But this is really important for maintaining the existing system, but also when you're upgrading in order to design and develop the upgraded new system. So in many cases, it's not feasible to completely replace the whole control system. There wouldn't be a good investment case for all the features offered by a new system. So how can we optimize the control system delivery of a safe, reliable operation with a minimum cost, minimum risk of downtime? So we advise you work with people who have the experience and knowledge of systems, of the different systems, to identify the critical components of the system and where is the most likely cause of failure that would have the most serious effect on operations. Then you can strategically target the investment and maintenance support and phase that appropriately to deliver the best value, match it with your investment availability, capital availability, and shutdowns, planned shutdowns. So some examples from ITS experiences are to follow. The first one is a case study of a chemical plant. It's a batch system, and this is a phased upgrade planned to minimise the risk and matched with the capital availability. ITS worked with the manufacturer to plan this upgrade and phased implementation. They identified they needed to take action because there were no more hardware spares available for their plant system, and there was also a bit of an issue because the documentation of how the system was built was not available. So then the first phase, ITS replaced the I/O cards with standard off-the-shelf Siemens PLC I/O, and then connected it on Profibus to the existing, happened to be a NOR batch system. And this ran for 2 years until the capital was available, and ITS supported it during that time. The second step was during a planned shutdown. ITS replaced the NOR batch system with Siemens PCS7, and then the benefits to the customer are listed here. First of all, they had a more reliable and modern system. They already had Siemens systems on that site, so they had more spares availability, and this was some commonality, so that was a good cost saving. And also the efficiencies of the plants could be improved and better information from the newer system. I'll just give you a couple of seconds to read a testimonial that we received from that customer. We have a library of similar testimonials commenting on the technical expertise of the engineers that work for ITS and how they can be flexible and focused on what the customer's requirements are. So the next example is a pharmaceutical project. The original system was actually a DEC VAX computer, which some people here might remember. That became obsolete, and the first step ITS did was to use an Osprey VAX replacement card in a modern computer. So that was low risk. We didn't need to change the operating system or code. The system needed to be revalidated on the new platform, which was a short shutdown, and that was then supported for 3 years. After 3 years, ITS removed the Osprey card and replaced the software with modern record systems based on the current PC. example is in the nuclear sector. This was a reverse engineering project for a nuclear facility. The systems code had been written in a defunct language, and then documentation not properly kept up to date as the code was changed. So the first step that ITS had to take was to convert the code into the sequential flowcharts. And they could then understand how the system was working. Then the next step was to identify a system that we could reprogram, use the system flowcharts to reprogram the new system, and then design, build, revalidate and test the system at ITS before then integrating it onto site over the month when the facilities could be shut down. My final case study is another chemical plant. So this particular plant had lots of smaller systems, over 15 smaller integrated processes, and they required a centralised view. And we're currently working on a kind of similar project in the energy sector where they need a centralised view. So we provided this system based on AspenTech InfoPlus 21 technology. We're a partner of AspenTech. We arranged a phased rollout across the many plants, and the investment allowed these following benefits. They had company-wide access to the real-time data from the plants. This saved a lot of management time by automating the reporting. That management time would then be used to do better analysis of where the production bottlenecks were, where energy was wasted, and how to better utilise the plants that they had. So actually probably a saving in capital because they could focus the investment on the appropriate parts of the process to get a better throughput. So I'm trying to bring together now the recommendations for critical systems in highly regulated industries. So it's important to protect what investment has already been made in the systems. So firstly, we recommend that you do an assessment of the obsolescence to determine what's critical to avoid failure and to avoid risk. Then you can put a plan or strategy in place to replace, upgrade, support these systems. So the next thing is to ensure the systems are properly documented and backed up in case of failure so that they can be recovered. Then if you're making any changes to the system, ensure that you have a method to get back to where you were. It's called a rollback or a disaster recovery. What's really important is the systems are regularly maintained and assessed. So having a support agreement with appropriate company or part of your organisation is important, and to maintain spares. So critical spares identified, which is the ones you need to make sure your legacy systems continue to operate. My colleague described a recent situation where a power cut on site caused the failure of a 7-year-old controller. It wasn't possible to get a replacement from the vendor who didn't hold any spares, and they had to wait over 4 weeks for a repair, and you can imagine the implication of that. So identifying what are the critical components of the system and having a phased upgrade plan. Replace whatever hardware you can that's obsolescent, especially on mission critical equipment, and that can potentially free up spares to keep the less critical equipment going. If the software version is not supported by the vendors and there are issues, it might be necessary to upgrade. This might also mean that the PC needs replacement. All this is going to become more important as technology improvements accelerate and vendors constantly add more features and functions. So referring back to Felix's earlier comment about a plethora of equipment or a plethora of versions, it's certainly not going to go away. So today I've tried to share some experience of good practice in managing legacy and obsolete systems. I've highlighted it might be difficult to justify the return on investment on a new or upgraded systems, especially while the system's running well. However, it might be possible to make a case based on the risk of unplanned shutdowns or downtime, which can be very costly. Another option might be to fund the investment from OPEX rather than CAPEX. ITS can help with some potential financial arrangements or payment plans, and we're happy to speak to you about this. So visit our stand or come and meet the ITS team, who are Joanne Rout, Mark Taylor, Trina Ives and Robin Harvey. As promised, here are my contact details, so please get in touch. I'd like to, at this point, thank my colleagues at ITS and also clients who generously gave their time to bring me up to speed with this topic over the last 15 months and also provide me with some such rich examples. Thanks very much for listening.